How does one get really lovely spectra like this on oxidized and reduced cytochrome C samples, which are quite turbid? This upper graph is a different spectrum. This is the actual absorbance spectrum. Years and years and years ago, a very clever man by the name of Britton Chance was among those developing a device called a dual-wavelength spectrophotometer, which has been used by cytochrome researchers for decades, 4 or 5 decades at this point. And I hold here a very interesting diagram which shows how the instrument works and how we advise that it be used, which is that it has 2 monochromators. This is one grading and a second grading, creating 2 monochromators. And here is a single light source. And the idea with this technology is that these 2 monochromators are producing different colors of light, one of which is the actual spectrum that you'd like to measure. And then a second one is a wavelength where there is no chemistry. There's only scatter, with the idea then that your difference in spectra are available to you, giving you the answer of the chemistry without the scatter effect. And it's quite a complicated setup. This was obviously a picture of the instrument in its original days. These days, just the optical bench is used with new electronics and new power supplies, creating a much more condensed, simple system. But one of the things, in addition to the dual wavelength technology that makes this such a useful tool for light scattering samples, is this enormous photomultiplier tube that is used for collecting the light scatter. So if we compare that with a typical photomultiplier tube, such as one that is used routinely in the equipment my people make, this is the face of the photomultiplier tube, and here is your cuvette. And so you can see that there is a nice match in size here for the Z height, which of course is where your light travels. So if you've got your measurement beam coming through to the other side, that it has the detector on the other side. This works beautifully as long as your sample is not light scattering. If it's light scattering, of course, then the light doesn't travel straight through, but it goes 360 degrees, which is where the scatter, the lost light, comes from. So enter this enormous photomultiplier tube on the original Amico DW2, which you can see literally is the same size, height as a cuvette. So the scatter coming off of this, at least on the front face, is entirely captured by this large columnating surface, which then focuses the light down into the detector component inside of this large tube. So over the decades, again, countless marvelous papers have come out of Fred Gingrich's laboratory, to name one very big P450 guy, and many of the people who have worked with him. And it's possible to still purchase one of these dual wavelength instruments from a company like ours that modernizes them. And if this is of interest to you, I'd love to talk.